Hello students. So in this video I am going to discuss a numerical based on radiation wavelength. So let's start this video. So I have written a numerical. Read out that laser emits a light near visible band if energy difference is, this is the energy difference from higher band to lower band. So we know that when an electron jump from higher band to lower band, it emits certain energy. If the energy difference is given between higher level and the lower level, so question is that find the wavelength of radiation. So we know that using the relation, that is how much energy is released. That energy is released, that is equal to h mu, where h is called Planck's constant. So h is called Planck's constant. That has a value of 6.624 into 10 raised to power minus 34 joule second. So this is the value of Planck's constant. Mu is the frequency which is given by c by lambda, where c is the speed of a light, that in air that is given by 3 into 10 raised to power minus 8. So mu equal to c by lambda. C is the speed of light, which is equal to 3 into 10 raised to power 8 meter per second divided by wavelength of a light. So here the energy which comes out to be, that is in joule, because it is in joule second and this is second inverse. So the unit of energy that comes out to be joule, but the energy is given as 2.36 electron volt. So first we have to convert the energy into joule, not in electron volt. So 1 electron volt, what is called electron volt? So electron volt is the unit of energy, that is amount of energy required to move one electron through a potential difference of 1 volt. I mean is, see how do we define the potential or the voltage? So voltage or the potential is defined as potential at a point, that is energy stored per unit charge. This is how the voltage or the potential is defined at a point. If charge is nothing but 1 electron, if 1 electron is moved through a potential difference of 1 volt, then the energy required is, or the work done in doing so is, that is called 1 electron volt. So what is the charge of 1 electron? That is equal to 1.6 into 10 raised to minus 19, and it is moved to a potential difference of 1 volt. So 1.6 into 10 raised to minus 19 joule. So 1 electron volt is the amount of energy that is required to move 1 electron through a potential difference of 1 volt, which is equal to 1.6 into 10 raised to minus 19 joule. So we are given the energy in electron volt, so we will convert this into joule by multiplying this 1.6 into 10 raised to minus 19. So that will be the energy in joule. So E equal to, that is equal to 2.36 into 1.6 into 10 raised to minus 19. This is joule. That much amount of energy is released. Now we will use this relation E equal to h mu. So E is equal to h mu, where mu is equal to c by lambda. Now this energy is in joule. So lambda wavelength is, so that is h c by E. So what is h? H is the Planck's constant, that has a value of 6.624 into 10 raised to minus 4 joule second. C is the 3 into 10 raised to 8 meter per second, and the joule energy is in joule. So that will come out to be, what is that? This 2.36 into 1.6 into 10 raised to minus 19. So this is the lambda. So value of lambda is comes out to be, so if you simply solve using a calculator, so that will come out to be 52 nanometer, or it will round out to be, yes, 52 nanometer. So this is the wavelength of a light.